This is M7, lesson 5-1, and the title of this lesson is Ratios. Okay. Now, the best way to describe what a ratio is to basically identify it in one word, and that is that they are comparisons. Ratios are comparisons. That is the plain and simple truth of the matter. Okay? We compare things all the time. So, we are going to take a moment and compare some things to see if we can come up with a way of writing ratios. Your book has a really good example, a couple of examples. They use the American flag, they use keys on a keyboard. Okay? What do you think, Parker? What do you want to compare?
Parker to Gandalf. My size and your size.
No, Parker.
What kind of thing are you thinking?
No.
You need to tell me what topics I need. What's the whole point? What kind of topics I need.
Okay, I've got a good one. Let's say that we have a pizza that is split into 8 slices. All right, so this is a pizza, not an R. Okay, and on the top of this pizza, we're going to have pepperoni, of course.
Do you want 3 pepperonis on each pizza? No.
The dots don't matter so much as the type of pizza. So we have pepperoni pizza on the top. And we have No, you cannot put sausage.
He's allergic to sausage. Really? Who is? Is he really? Gandalf is.
Okay, so we have mushroom pizza on the bottom. Okay, and of course there's cheese here. All right. Now, how many total slices do I have? I do. I have 8 slices. And how many are pepperoni? Yes? 4. And how many are mushroom?
4.
Yeah?
4.
4. Okay. So I have really several things that I can look at here. I have total slices, pepperoni, mushroom. Okay. But we're going to make some comparisons here. Remember, ratios are comparisons. So I first want to know how many of the slices compared to the total are pepperoni. Okay? So we start with the first comparison, and I am going to go ahead and just walk through this. So this is what we're going to call example 1. Well, that's just the scenario. So we have example 1 here, and the example 1 is that we want to compare total slices to pepperoni slices. So that's what we're going to compare in example 1. How could I compare this? How could I write it? So how many total slices do I have? I have 8. And I could say, well, I have 8 to how many? Pepperoni. 4. Okay. This right here is a ratio. It's a comparison of one thing to another. So I have 8 total slices to 4 pepperoni slices. But ratios can be written 3 different ways. That's the cool thing about them. They can be written 3 ways. This is actually the least common way we use ratios, is with the word to. Okay, so they can be written with the word to. They can be written with a colon, so 8 to 4, like so. That's the second way to write them. The third way to write a ratio is how? Yeah? What is it? It's not multiplication. The slash.
Like an 8 slash
we're going to put it as 8 over 4. All right. Now, as written, ladies and gentlemen, these are ratios. Okay? We don't want to think about them necessarily in terms of just fractions or as a statement or whatever. It's 8 to 4, 8 colon 4, 8 over 4. Okay? This is how we would represent total slices to pepperoni slices. Now, when you write it in terms of 8 over 4, can that be simplified? It can. How can I simplify it?
Does that mean an estimate or
Okay? Simplify. Yes. Jacob? I could do 8 divided by 4, which is what? 2. Yep, so that would be a 2 in the top. And 4 divided by 4 is? 1. Okay, so the simplified version of this is that there are 2 slices, or there are 2 total slices for every pepperoni slice. Well, we would say that there are twice as many total slices as there are pepperoni, but we aren't necessarily going to write this differently, okay? We want to keep it in terms of 2 over 1, because if we lose the 1, it's no longer a comparison. So ratios are always going to be written as, with the word 2, with a colon, or as a fraction, no matter if it's over 1. That's the tricky thing about ratios, okay? Now, at your tables, I want you to come up with a ratio of pepperoni slices to mushroom slices, okay? So right now, write that ratio 3 different ways, okay? Do that for me right now, please. You're comparing pepperoni slices to mushroom slices. I didn't. I did total slices. You are comparing pepperoni slices. Oh, yeah. Well, there's no such thing as the same thing in a ratio. You're comparing one thing to another. It's a comparison. Those two things might have the same value, but it's still a comparison. So pepperoni slices to mushroom slices. Kind of feeling some pizza for dinner. We'll see.
So even if it's an improper fraction, it doesn't matter. We can't convert it.
Right. You will never write a ratio as a mixed number.
Okay.
Nope. Which will make it simpler, to be honest. All right. Macy, I know you know the answer to this. How many pepperoni slices am I dealing with here? 4. Yeah. And I can use the word 2. And how many mushroom slices? 4. Okay. So we could say there are 4 to 4. Okay. There are 4 pepperoni slices to 4 mushroom slices. How about another comparison? What could we come up? Yeah. Yep. So foreign. All right. 4 colon 4. Or what? 4 over 4. I can simplify this to 1 over 1. No. Ratios always have to have 2 things that you're comparing. So yes, in theory, mathematically, Savannah's correct. This is 1. However, if you're writing it as a ratio, you have to write it 1 over 1. And the way that we would say this is for every pepperoni slice, there is a mushroom slice. Okay, so really that's what we're getting to here. For every pepperoni slice, there's a mushroom slice. That's the point here. So these are ratios. I really don't think that you're going to find this is going to be overly difficult. Your objective this evening is to write these ratios one of three ways. That's really what you're getting at tonight. Okay. There is another. There are other ways to think about ratios. Okay, and I'm going to kind of get to this here in a second. Okay, that's fine.
What did we write down for the first one?
For the first one,
Yeah. Nothing.
I can go back in a little bit. Okay. Yes? When we're done. All right. Now, I want to get to how we could draw this scenario, okay, in terms of a picture or a diagram. All right. Well, we didn't. We wrote it out, but we haven't drawn it. So we did. Oh, I guess you're right. We did draw it as a pizza, didn't we? Right here. There was a pizza. But I want you to think about it in terms of, if you take a look at page 228, they have kind of like a little block diagram, kind of a diagram where they have a purple block, a green block, and a blue block. So I want you to think about this pizza example in terms of this. Oftentimes in a ratio, you're comparing pieces, right? You're comparing pieces of a whole. So here we might say that the full pizza represents 8. And it's being split up into smaller sections, okay? And we will call maybe this 4 slices pepperoni, so I'll put a little P here, and 4 slices mushroom. But we can split it up even further, can we not? We can split it up so that there are what? Okay, we could go 2, 2, 2, or we could even go all the way down to 1, 2, 3. Well, that's not very even. 1, 2. And so that we have individual slices represented here. So there are a lot of ways to represent or compare ratios. You could compare one slice to the whole. You can compare one slice to half the pizza, etc. And we will look at quite a few more of these today. All right, let's move on to another example so that you get some more diversity with this. Okay, and what we're going to do is we're going to talk a little bit about, okay, what happens if there's units involved? So I'm going to give you an example of this. Let's say we're comparing the ratio, okay, 2 feet to 30 inches. 2 feet to 30 inches. Well, the first thing you should understand about a ratio, Jackson, because this is incredibly important, is that when you're comparing two things, you have to compare things that have the same units. So like in the previous part, we compared slices of pizza. Great. They might have had different toppings, but they were slices of pizza. Here, we cannot compare these because they are in different what? Yes?
Like measurements?
They have different measurements. They're different units. So when you're creating a ratio, you have to convert them to the same units. So, can anyone tell me how many inches is 2 feet? Yeah. 24 inches. Once I make that change, 24 inches to 30 inches, I have now started the process of comparing my ratios. Okay. We will look at what we call unit rates, and that'll be next week. And that's when you can compare things with different units. But ratios have to have the same units. So I'm going to write that at the bottom. Ratios are a comparison of two values that have the same units. That's a really important idea here. And then we'll see that play out here. So 24 inches to 30 inches. Great. They have the same unit, inches. All right. Now, so now I don't need to write the units. Okay. I can compare them straight up. 24 to 30. Great. There's one way to write it. Okay. How else can I write it? 24 to 30. How else can I write this? There are 3 ways to write ratios. Yes.
24 colon 30.
24 colon 30. So what I have here is I have the first way I can write it, the second way I can write it. Oh, and there is a third. Oh, I love it. And Millie's got it.
You could write it like
24 over 30. Okay, that's the third way to write it. Can I simplify 24 over 30? Oh, I can. They're both even values. Okay, let's divide top and bottom by 2. I don't want it. Okay, if I divide top and bottom by 2, what do I get? Yes, Savannah. 12 over 15. Okay, that's great. That's what we call an equivalent ratio. Oh, you are right. We're going to get there in just a minute. This is called an equivalent ratio, which means that it is got the same, basically the same comparison. I'll show you what I mean by that. It's called an equivalent ratio. We'll get to that in just a minute. But Jacob's right. We can definitely simplify this further. What goes into both 12 and 15, Millie? 3 does. 3 goes into 12 how many times, Savannah?
4.
It does. And 3 goes into 15 how many times, Savannah? 5 times. All right, I would ask that at this time you please get out a calculator. I'm going to have you test something here. Okay? I'm going to have you test something here. Okay, on your calculators right now, I want you to take 24 and divide it by 30 and hit equals. Okay? And you get, Miss Verity, what do you get?
0.8.
I do. You should, and that is correct. You get 0.8. Great. Okay. Mr. Parnan, take 12 and divide it by 15. Oh, 0.8. How fascinating. And Savannah, take 4 divided by 5. I think we can kind of guess what's probably going to happen here. 0.8? Yeah, it is. Okay. Do those fractions look different? They do. They do. But they're equivalent ratios because when you simplify them to a decimal, which we don't do very often. I'm only doing this as a teaching moment because ratios have to show a comparison. When you simplify them to a decimal, that shows you their true value. Is their true value of all 3 of those exactly the same? Do they all equal the same value? What do you think, Caitlin? Do they all have the same decimal answer? They do, which means they have the same value. So even though they look different, they have the same value. We would say they're equivalent ratios, but really if we were to remove the whole comparison thing, they're equivalent fractions. They're equivalent fractions. This is not a new idea. It's just a different way of thinking about a comparison. So if I have 4 people to 5 people, or 12 people to 15 people, or 24 people to 30 people, I have the same ratio. Or the same comparison. I'm always going to have a ratio of 0.8 roughly. So that's how that kind of works. So I want to take a look at a problem in your homework here. Okay? Here's how this works. Let's look at number 24. This is actually part of your assignment, so if you want to write it down right now, that would be ideal for you. And here's what number 24 is asking you to do. It says tell whether the ratios are equivalent or not equivalent. Okay, so we have 2 options. They're either equivalent or they're not equivalent. Here are the ratios. 6 to 7 and 30 to 36. Okay, I'm going to tell you it's really much simpler if you write them as fractions and compare them. Okay, so I'm going to write this one as 6 over 7, and I'm going to write this one as 30 over 36. And the question we have to ask ourselves is if they are equivalent, they will equal each other. But if they're not, they won't. So you have 2 options. You either have an equals or you're going to have the not equal sign, which is the equals with a slash through it. So, and I'm going to erase that in the middle. We're going to have to pick. Are they equal? Are they not equal? Hold on, Savannah. You can go about this 2 ways. If I was looking at this, I would be like, what could I multiply by 6 to get 30? Yeah. I can multiply it by 5. All right, so I'm going to do that right now. I'm going to multiply this by 5, and that would equal 30. Cool. The top numbers could be equivalent. Oh, man, I'm on a roll. But what I do to the top, I must do to the bottom. So I have to multiply the bottom by 5. Okay? And that would equal what?
35.
Oh, shucks a muffin. Nope, that's not going to equal 36. So the ratios cannot be equivalent because the bottom is not going to equal 35. It actually equals 36. So, are they equivalent? No, they're not equivalent. So if I had to write these on a piece of paper or give you an answer, I would put the equal sign and then I'd go ha 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 slash, and they're not equivalent. Now, the other option is you simplify the larger ratio. If it can simplify to the smaller ratio, they're equivalent. All right? Take a look, for instance, at, let me make sure I'm doing this. Take a look, for instance, at number 23 in your book. Okay? Take a look at number 23. This is not part of your, actually, it is part of your homework. Excuse me. Because you're going to have a few odd numbered problems tonight. So this might be to your benefit. 18 over 24 and 3/4. Instead of trying to set these equal to each other, page 230. Instead of trying to set these equal to each other, here's what you do. Simplify the larger fraction. Simplify the larger ratio. So, I know Katie Fady knows this. Katie, what can go into both 18 and 24?
6.
Oh, wow, that's very good. I was thinking you might say 2 or 3, but you said 6. You jumped right to the big guns. Woohoo! Pulling them out. Yes, that's exactly what I would have gone for. That was fantastic. So, we can divide both top and bottom by 6. Okay, 18 divided by 6 is what value? Oh, Millie. Oh, wow, Millie. Ooh, you look different. Okay? And sound different. All right. Yes, it is 3. Nice work. And 24 divided by 6 is? Yeah, Millie. It is. It's 4. Does that, when simplified, equal the other ratio? It does. So are these equivalent ratios? They are. And so for 23, the answer would be they are equivalent. 24, they're not equivalent. Okay? And that's how you would kind of compare that. All right. At your tables, last but not least, and then I'll give you your homework for tonight, which we've already done 2 problems, which is nice, and you'll have plenty of time to finish it. Could you please, at your tables right now, do number 28, and I'll read it out loud. Your math class includes 15 girls and 10 boys. Okay? I want you to stop there. I want you to create a ratio of boys to girls. I'll write that down on my, up so you can see it. I want a ratio of boys to girls. I want the ratio written 3 different ways, and I want to see at least one equivalent ratio. I'll give you 3 minutes to do this, starting now. Number 28 on page 231. This is not part of your homework, but I just want to see that you can do this. So I want you to give me a ratio of boys to girls. I want to see it written 3 different ways. And I want to see at least one equivalent ratio. Let's go. Well, we can definitely do this. Boys to girls. Boys to girls. Very good. Now, you have to write it 3 different ways. So you're going to write it with the word 2. You're going to write it with a colon. And as a fraction.
You guys are overthinking
Yeah.
it.
It's not meant to be difficult. You're going to write it 3 different ways.
I know that. Make it an equivalent. What do you mean?
You just simplify it.
Oh, I did that.
Well, then there you are.
You have to write out like. Oh, you have to simplify it. Or wait.
You simplify it last. Let's take a look. Okay. Yeah, you did what I wanted. Now, we just want to make sure it's boys to girls. boys to girls. The way we write our ratios has to represent boys to girls. So is that number 15 represent boys? Oh, it's got to be written boys to girls. Boys to girls. Yes, yes. Boys to girls. Oh, but I want you to switch it around. That's why I said it very specifically that way. So there are really two ratios here. You can go boys to girls or girls to boys. I want boys to girls. Oh, the way it's worded is important, which is why I did this. Boys to girls. Yeah. So I will write it. Here we go. Boys, there are 10 of them. Girls, there are 15. Put the word 2 in there, and boom, shakalaka, you got your first ratio. Then, all I have to do is rewrite that two different ways. 10 colon 15 and 10 over 15. There are my three ratios. Now, an equivalent ratio would just be a simplified version of this. So Macy, give me 1. Okay, I could divide top and bottom by 5, and I would get... So this would be my equivalent ratio, or the ratio written in simplest form. I really think that you guys have got a pretty decent grasp on this. Okay, I'm guessing you've probably seen something similar to this before. The math is not really anything different than working with fractions. It's just thinking of it in terms of comparing things. Okay, we do this all the time here at school as teachers. When we set up our classrooms, we try to make sure that we have equivalent, let's say, breakdowns of boys to girls. We don't want to stack one class and not the other. We want to have equal representation in both classes.